So today we are going to be talking about Chapter 3, Section 6. And our essential question is, how can I find the focus and the directrix? So first we have our definition of focus. Focus is a fixed point in the interior of a parabola. Remember, our parabolas are U-shapes, such that the set of all points x, y of the parabola are equidistant from the focus and the directrix. Again, the focus is a fixed point in the interior of a parabola such that the set of all points x, y of the parabola are equidistant from the focus and the directrix. Next is directrix. So the directrix is a fixed line perpendicular to the axis of symmetry. And remember, if two lines are perpendicular, then they cross to form 90-degree angles. So the directrix is a fixed line perpendicular to the axis of symmetry, the AOS, such that the set of all points x, y of the parabola are equidistant from the focus and the directrix. If you need a little more time to write down the definitions, I'll leave it here for just another minute or two, and then we'll move on to our next piece. So when we have our parabolas, this is our axis of symmetry. Remember, our axis of symmetry is the line that cuts our parabola into two equal or symmetric pieces. So we have our parabola here with our vertex, which is our either lowest or highest point. In this case, it's our lowest. Our focus is somewhere on the inside, the interior, and it says the focus is in the interior of the parabola and lies on the axis of symmetry. Then this blue line is our directrix. The directrix is perpendicular to the axis of symmetry. So my axis of symmetry is going vertical, and then my directrix is horizontal. The vertex lies halfway between the focus and the directrix. So in our definitions for focus and directrix, it said that the x and y, any point on our parabola, is going to be equidistant from our focus and our directrix. So if I'm looking at this focus and I pick some point on my parabola here, this length from the focus to my parabola has to be the exact same distance as from my parabola down to my directrix. Same thing here. If I go to this point on my parabola, this segment has to be the same exact length as this segment from the parabola to my directrix. I'll give you a second to write that down, and we'll move on. So we've been talking about how to graph parabolas, and today we're going to be working with parabolas that go in all different directions. So far, they've either gone up or they've opened down. Now we're going to look at some that don't open up or down. They might be opening left or right. So next we have our standard equations of a parabola with a vertex at the origin. So first we have is our vertical AOS, and so we know if it's a vertical AOS, our axis of symmetry is x equals 0. So these are our two options. Either our parabola is going to open up our vertex is at 0, 0, or our parabola is going to open down with our vertex still at 0, 0. If it's opening up, then our focus is going to be at the location of 0, p. We don't know what that p is right now, but we will get to that in a few minutes. Our directrix is going to be the equation y equals negative p. Now this negative p means that it's the opposite sign from our focus. And then our equation for all of our problems today are going to be y is equal to 1 over 4p x squared. And that p is coming from our focus, which is the opposite of our directrix. So it's going to be going up if p is greater than 0. On this side, it's going to be going down if p is less than 0. And this time our focus is going to be down here. It's still going to be 0, p. And our directrix is still going to be y equals negative p. So I'll give you a minute to copy this down into your notebook. I color-coded mine so that I can see my directrix, my focus, and my parabola, and they stand out from my paper. So if you'd like to color code, go ahead and color code. Okay, next we have our horizontal axis of symmetry. So that means that we're going to have y equals 0 this time. So the last one was x equals 0, this one's y equals 0. And this time our parabolas are going to be going to the left or to the right. So our equation is going to change a little bit. This time it's going to be x equals 1 over 4 times p and then y squared. Our focus, since we're on our side, is now going to be p comma 0. And our directrix is going to be x equals negative p. That negative p still means that we have the opposite sign of our focus. So it's going to be opening to the left for any p value that is smaller than 0. So all of our negative p's. And then we have that it's going to open to the right for all of our positive p's for p is greater than 0. Now we'll talk about how we're going to end up graphing these in just a minute or two. I want to give you a little bit of time to copy this down on your page. As you can see, I kept my color coding. My focus is always my pink. My parabola is always my green, and my directrix is always my blue. I want to stay consistent because it's going to make it easier for things to stand out. Okay, number 1. Our goal is to identify the focus, directrix, and axis of symmetry of negative 4x equals y squared, and then graph the equation. So first thing that we want to do is we need to rewrite our equation in standard form. So I know that if I want to rewrite it in standard form, since my y is squared, I have y squared, I know I need to solve for x. So to solve for x, I have negative 4 times x. So I want to divide by negative 4 on both sides. Well, if I look back here at my notes and I find my y squared, I know I'm going to be in this case here where I'm talking about horizontal axis of symmetry. And so I need to put it in the form of x equals 1 over 4p y squared. So I need to make it look like that, which means that when I solve for x, I'm going to write it as 1 over negative 4 y squared. So my next goal is I need to find P because I have to have P in order to find my focus. So I know that this is -4 on the bottom. I know in my original I have 4 times P. Since they're in the same location of these two equations, they have to be equal to each other. So I'm going to start by saying -4, which came from this part, is equal to 4P, which came from my original equation. So if I divide both sides by 4, because my goal is to get P by itself, I have -4 divided by 4 gives me -1. So I know P is equal to -1. So then I want to come back here and I want to look, and it says my focus is P, 0. My directrix is Y equals -P. So if my focus is P, 0, I'm going to plug in -1 in for P. So I have -1, 0 is my focus. My directrix is X equals -P. So I plug in the opposite sign of this is a +1, so I have X equals 1. And I wrote myself a little note, I need the opposite sign from the focus. My axis of symmetry is Y equals 0. My next goal that it asked me to do is it asked me to graph. Well, I know that my vertex is going to be at 0, 0. Then I'm going to go and I'm going to build my table that we are all familiar with our out 1, 2, 3, our y squared, or x squared is usually what we use, but we're using y squared because we're working on the side, 1, 4, 9, and then our a, from up here, we found a was -1/4, so I plugged in -1/4 y squared, so I have -1/4 times 1 equals -0.25, because the decimal is a little easier to graph. I have -1/4 times 4 gives me -1, and -1/4 times 9 gives me -2.5. So now that I have that, I want to go and I want to build my graph. So I'm going to come over here and I'm going to build a graph over on this left side with my X and my Y. So I wrote a little note. First thing you want to do is you want to make your X and Y axis. Then what you want to do is you are going to take your page and you are going to spin it 90 degrees counterclockwise, so your X is where your Y typically would be. Now I'm going to use my table, so it says if I go out 1, I'm going to go down 0.25. So I started at 0, 0, and I went out 1 to the right, down 0.25, back to my vertex, out 1 and down 0.25. It says if I go out 2, I'm going to go down down 1, because it's a -1, so I go back to my vertex, out 2 and down 1, out 2 and down 1. The last row says if I go out 3, I'm going to go down 2.25. So I went out 3 and down 1, 2, and 2.5. Out 3 and down 2.5. Then I can build my parabola that's laying on its side. The last thing that I need to add in is I need to figure out where my focus and directrix is. So if I come back to the regular direction that my graph should be, it says that my focus should be at -1, 0. So that tells me I'm going to go to the left 1 and put a dot and label it as focus. My directrix is X equals -P. So X equals 1 is what we came up with. So I went to X equals 1, and then I drew a line going up and down through that because it has to be perpendicular to my x-axis, and labeled it as my directrix. So here is the graph for number 1. Number 2, same directions. We want to identify the focus, directrix, axis of symmetry of y equals 0.5x squared and graph the equation. So first thing I have to do is I have to rewrite it in standard form. It's almost in standard form, but I have to have a fraction, not a decimal. So I know 0.25, I know that 0.5 as a fraction is 1/2. So then I know my basic equation is going to be y equals 1/4p. x squared. So I have to find p. So I had 2 and 4p are in the same location, which means they have to be equal to each other. So I have 2 is equal to 4p. I divide by 4, and 2 divided by 4 gives me 1/2. So p is equal to 1/2. Now if I come back to here, and it says if I have my y equals and an x squared, then I'm going to be in this case up here, where it's going to be either up or down. And my focus is now going to be 0, p. So I know that I have p is 1/2, so I have my focus 0, p is equal to 0, 1/2. My directrix is now y equals negative p, so the opposite of a positive 1/2 is a negative 1/2. So I have y equals negative 1/2, and then I wrote myself my little note, opposite sign of the focus. My axis of symmetry is now x equals 0. My vertex is still staying at 0, 0, so when I go to graph it, I have my vertex is at 0, 0, and then my a is 1/2, so I have my table out 1, 2, 3, x squared is 1, 4, 9, and then a is 1/2, so I have 1/2 times 1 is 0.5, 1/2 times 4 is 2, and 1/2 times 9 is 4.5. So I went ahead and I graphed my parabola, and then I needed my focus and directrix added onto my graph. So my focus is at 0, 1/2, which means I don't go left or right, I just go up half of a block. And then my directrix is y equals negative 1/2, so I went down 1/2, and then I drew a horizontal line and labeled it as my directrix. So I'll give you a minute to finish copying this one down. Okay, now we're going to talk about how we write our equation if we only know one piece of information. So here is our graph that we have. So it has the x and the y. We have our parabola is opening down, and we know that our directrix is right here. So first thing I want to know is, where is our directrix at? Our directrix is at y equals 3. Well, we know our directrix is usually y equals negative b, but we have y equals 3, so I need to solve for p. Since these are in the same location, they have to be equal to each other. So we have 3 equals negative p. I divide by negative 1 on both sides, and 3 divided by negative 1 gives me negative 3. So I know p is equal to negative 3. Now if I have this graph that's opening down, and I go back to my little helpers over here, it says if it's opening down, my equation is y equals 1 over 4p x squared. So I'm going to go ahead and I'm going to copy that down over here. So I have y equals 1 over 4p x squared, and I want to plug p in. So when I plug p in, I end up with y equals 1 over 4 times negative 3 squared x squared, and negative 3 times 4 gives me negative 12. So my equation is going to be y equals 1 over negative 12 x squared. And that's my final answer. Number 4. We want to write an equation with a focus of negative 2, 0. So our focus is in the form p comma 0. So p is negative 2. If I refer back to my notes a couple pages back, it tells me that if I have p comma 0, then I know I'm going to have my equation is x equals 1 over 4p y squared. So I'm going to replace this p with negative 2. So I have x equals 1 over 4 times negative 2 y squared, and x is equal to 1 over 4 times negative 2 is negative 8, so I have x equals 1 over negative 8y squared. And that is the end of section 3.6.